Okay, we're going to talk about Argand diagrams, modulus, and converting from Cartesian to polar and also from polar to Cartesian. Before doing this assignment, you should have done the H8E assignment with Revision Village. Basically, this is a really good YouTube assignment where you have to there's a guide that shows you how to convert from Cartesian to polar to Euler form, and then and back. But we're going to talk about that in this assignment too. So do this assignment H8E.1 first. Okay, so here we go. So the first thing we're going to talk about is if we've got a point, 2 plus 3i, I'm going to go 2 in the real direction and 3 up in the imaginary direction, and that gets us this point 2 plus 3i. Okay, so the first thing we're going to talk about is the modulus. Now, when we were doing vectors, we talked about magnitude, right? I can't see that, can you? We talked about magnitude. What is magnitude? What is modulus? Basically, it's the length of the line. Okay, it's the length of the line. That's the important thing. Okay, so the modulus is the length of the line. And then we're going to talk about argument. The argument is the, sometimes they write it like as arg-z, but it's the angle between the real axis and the modulus line here for our function, for our vector. So so this first example here was just calculating the modulus. So the first example here is 2 plus 2i. So I go over 2 in the real direction and 2 in the imaginary up, and so then I get this line. And in order to find the length, I need to use the distance formula. So I take, I go out in the x direction 2, I take that value and square it, and I go up 2, I'm going to go 2 squared, so we'll get 2 squared plus 2 squared. So 2 squared is 4, so I end up with 4 plus 4, which is square root of 8. Or you could simplify it with your calculator like this. The next one, I've got this vector is 3 minus 4i. So I'm going to go 3 in the real direction and down 4 in the imaginary direction. And so my modulus is the length of this orange line. So I'm going to take the 3 and square it. I'm going to take the negative 4 and square it. So then I end up with 9 plus 16. 9 plus 16 is square root of 25, which gives me 5. Last one here, I've got negative radical 3 plus I. So in the real direction, I'm going to the left radical 3. And in the imaginary direction, I go up 1. So there's my modulus, my line. So I take the square root of, so I've got the negative square root of 3. I'm going to square that. And I've got the 1, and I'm going to square that. Well, the square root of 3 squared simply gives you 3. And 1 squared gives me 1. So I have the square root of 4, which gives me 2. Okay, so that's finding the modulus. Modulus is pretty straightforward. Distance formula shouldn't be too hard finding the modulus. The argument is what's a little bit harder. Okay, so it's the angle between the real axis and our line. So I'm going to, if you want to pause, you can copy this down, but I'm going to just do this from scratch on clean paper here. Okay, so so the first one, I've got 2 plus 2i. So I'm going right there. Okay, and over 2, up 2. So I want to find this angle right here. So in order to find that angle, I know I'm going over the same amount as I'm going up. So one way to think of this, so this is the angle I'm working with. So this is the opposite side, and this right here is the adjacent side. So if I'm working with opposite and adjacent, I'm going to use tangent. Okay, so this value here is a 2, that value there is a 2, so I got tangent of my angle is going to equal 2 over 2. So, and that's going to give me 1. And so if I get my calculator and I do inverse tangent, inverse tangent 1. Now let's make sure, what mode am I? That's radian mode. If I'm in degree mode, yikes. If I'm in degree mode, we get 45 degrees. And that makes sense, right? If I look at my unit circle, at 45 degrees, this divided by this, I would have a value of 1 for tangent. So we would either write an answer of 45 degrees or pi over 4. So the argument, I'm going to call it arg z, is equal to 45 degrees, or we would say pi over 4 if we're talking about radians. Okay, let's look at the next one. It says 3 minus 4i. So I go over 3 and down 4. And that puts me right there. I went over 3 and down 4. So now I've got my line. And we're finding the argument. We're finding the angle. So notice this angle is going down, right? And what we mentioned on the earlier page, I'll just write it down here. The argument is between the x-axis and going either this direction or this direction. Okay, so it's between negative pi and pi. Okay, so we're trying to find the angle that we have from the x-axis. Unlike when we're doing bearings, we start north is 0. With imaginary numbers, the x-axis is 0. Okay, so here we're going to have a negative value because it's going down. So once again, we have, this is the opposite side, this is the adjacent side, and we're trying to find this angle here. So I could write tangent theta equals opposite, which is this length of there is 4, and adjacent over is that's 3, and so if I put that into my calculator, inverse tan of 4 divided by 3, enter. Oh, and that's 53 degrees. But I think they are going to, for the most part, just want radians. So I go to we go to radian mode. Let's try that again. And so theta is equal to, the argument is equal to 0.927 radian. Okay. And the last one, it's going down, isn't it? So this is going to be negative 53 degrees, negative 0.92 radian, because it's going this way from the x-axis. So these are negative values, and going this way is positive values. Okay. Let's do the last one. Negative radical 3 plus I. So negative radical 3 this way and plus 1. So it's kind of up there. So negative radical 3 and this way up here. Okay. So the easiest way to look at it is, okay, so we're trying to figure out this angle here, right? But if I'm using tangent and that sort of thing, I'm going to try to find out this angle, the blue angle there, and then subtract that from pi. So, so this here is opposite, this here is adjacent, and so to find this angle, I'm going to call it alpha because I don't want to call it theta. So to find angle alpha, it's opposite over adjacent, so tangent alpha is equal to 1 divided by square root of 3. And then I'm going to get this angle (1 divided by square root of 3). Right? Enter. And I'm going to get 0.523. Or 524. Okay. 0.524. Okay. So that's alpha, but we're trying to find this green one, right? So to figure out that green one, let's call it arg z subscript a, because this is problem number 3, right? So arg z subscript is equal to pi minus 0.524, because if I'm subtracting the blue one there, then I'm going to get arg z. Okay. So then pi minus that value gives me 2.62. Okay. Let's do the next one. Okay. Now this one here, I didn't see anything like this on the test. I'm going to walk through it, but just so you know, I don't think this is going to be on any kind of test. There was no homework problems on this one at all. So find the area of the triangle with the vertices here. Okay, so we're using the same vertices. To find the area of a triangle, I go to our formula packet. This is something that we learned first year of IB. And if I've got a triangle here, we've got our included angle, and A is that length there, and B is this length there, and we've got our included angle in between. Okay, and that's how you find the area of a triangle. So we're going to be using that formula here on this problem here. And so we've got 3 triangles here. So I'm just going to do this on this other paper where it's clean. Okay, so I'll just do one of the triangles so you get the idea, and then we can move forward. So on the previous page, so this right here, this line right there is Z3, and this line right here is Z1. And on our previous assignment, so we need the length of these lines here. So this length here of Z3, we figured out was 2 on our earlier thing. So this magnitude here is 2 from there to there. I'm just doing one triangle just to give you an idea of what's happening. Okay, this length there we figured out was 2.83. I'm just going to write square root of 8. Okay, and we need this angle right here. So how do we get that angle? So we know this angle right here I'm going to draw this really big over here. Okay. We know this is 8. We know this is 2. Sorry, square root of 8. And between here and here, what was that angle between Z1? This is Z1, right? So between Z1 and there, we know that angle is 0.785. And from here to here, that whole thing we know is 2.62. So to figure out this angle, that angle is going to be 2.62 minus 0.78 for that angle. This angle. So if I put that into my calculator, we've got 2.62 minus 0.78. So that angle is 1.84. 1.84. That is my angle. Okay, so I know this length here is 2. I know this length here is square root of 8. And the formula for the area of a triangle is 1/2 side sine of this angle. So we said that's 1.84. That's my angle. And we know that this one length is 2, and this length here is square root of 8. And you may notice that this matches what we have here. We've got our square root of 2 right there, square root of 8 right there, 1/2, and the sine of 2.6 minus pi over 4 is this value. So anyways, you did do this 3 times, but I'm not going to have this on the test, but I wanted to explain it because I thought it was worthwhile. Okay. Let's talk about converting Cartesian form, rectangular form, into modulus argument form or polar form. Okay, so hopefully you saw the revision village explanation. It's really, really good. But I'm going to explain it so that you know how to do it from here. So the first thing we're going to do is get the modulus. So we know in the x direction we're going over 2, and in the y direction we're going up 3. Okay, so we're going to get the square root of 4 plus 9, which is equal to the square root of 13, which is approximately 3.61. Okay. To figure out this angle, the argument, we need to recognize that this here is the opposite, and this right here is the adjacent. So, we're going to say tangent of theta equals opposite over adjacent. So this value here is 3. That value is there is 2. So we have 3 over 2, opposite over adjacent. So if I do the inverse of that, then I can get my answer. So second tan, 3 divided by 2, and I'm going to get 0.983. So theta equals 0.983. So polar form looks like this. It looks like we've got our modulus and cis and our angle. Okay, so our angle is this, and our modulus is this. Okay, so we can write out our answer as 3.61 cis 0.983. And now we've written it in modulus argument form. Okay. So now we're going to convert it from polar form to Cartesian form. So we're going to convert this from polar to Cartesian form. Okay, so they've given you this information. What they've given you is, we just said polar form was z equals the modulus cis theta, right? This is polar form. What they've given you is you have 3 cis 0.4. This is what they've given you. This is polar form. So in order to convert this to Cartesian form, we're going to use the relationship that we got from Revision Village, which is, what does cis mean in the first place? Cis means cosine theta plus sine theta I. So what we really here have is 3 times cosine 0.4 plus I sine 0.4. Okay, this is a very important relationship, that if I'm converting from polar to from polar to Cartesian, that you need to be aware that cosine theta plus sine I theta is the same thing as cis theta. So our real part is the modulus times cosine theta. The imaginary part is the modulus times sine theta I. So I'm replacing cis with the angle of 0.4 with cosine 0.4 plus I sine 0.4. And now it's just simple distributive property with the 3. So I've got 3 cosine 0.4 plus 3I sine 0.4. Okay, so now I'm going to put that into my calculator. 3 cosine 0.4 equals 2.76, and 3 sine 0.4 is equal to 1.17, and don't forget the I. Okay, so now I have written this in Cartesian form, or they sometimes call that rectangular form. Okay, so the form A plus BI is Cartesian form. Let's do one more example. Okay, so the polar form that they've given us is z equals, my modulus is 5, and cis 3.4. Okay, so we know that cis, we can write this as cosine 3.4 plus I sine 3.4. Okay, and once again we have our modulus of 5. Okay, so I'll do this one more time on the calculator. So I've got 5 times cosine 3.4, and I get negative 4.83. And I do 5 sine 3.4, and I'm going to get negative 1.28. And now we have written it in Cartesian form. Okay, this is the most important thing that we're going to be using for the rest of this chapter, is converting back and forth from Cartesian to polar and polar to Cartesian. Okay, so anyways, what I was just saying earlier, that they've written right here. So cis theta is equal to, is the same thing as cosine theta I sine theta. That is so important. Important. Okay, so hope you remember that. Okay, so let's talk about these problems here. We got to move on because this video is getting really long. Okay, so if I've got 8I, the angle just goes to there, so my argument is pi over 2, and this distance from there to there is 8. I didn't even need to use the distance formula because it's only going up like that. Let's look at a different one. -7. So to go from here to here, the modulus is going to be 7. And the argument, the angle that goes from here all the way to there, that angle is going to be pi. Okay, let's look at a different one. 12. So that means I'm going to go this way, 12. So my modulus is going to be 12. And it doesn't twirl at all. So my angle, the argument, is going to be 0. And lastly, what color have I not used? Purple. Okay, so the next one is -5i. So I go down here to -5i, and this distance from there to there is 5. Okay. Okay. And this angle here is -pi/2. Because I'm going from here down to -pi/2. Okay, going from Cartesian to polar, we just did some examples like that. So we found the modulus using the distance formula, and then I figured out the angle. This angle right there. So we have my adjacent is 2, the opposite is -3. We figure out the angle, but since it's clockwise, it's going to be negative. Okay, so I've shown all the work on this problem, so you might want to hit pause and check your answers. I'm not going to explain all these through because it's exactly the same thing we just did. You might want to hit pause and check your answers. Alrighty. Okay, this is a little different because they didn't want you to use the calculator. So they wanted you to, so first of all, the modulus, same process. It shouldn't be any big deal. Okay, using the distance formula. But to find the angle, so on this one here, if I go over 4 and up 4, you should recognize that's going to give me a tangent equals 4/4, which gives me 1. And then I'm supposed to see, oh, if tangent theta is equal to 1, then the argument has to be pi/4. Okay, so my argument has to be pi/4. And I could also notice that from my unit circle. So pi/4. Okay. Here I go over 2 and I go up to radical 3. So using the opposite side, which is 2√3, and my adjacent side is 2, I can write this as 2√3/2, which simplifies to radical 3. And radical 3, this divided by that is going to give me radical 3. But they already told you that up here. If I've got tangent, the inverse tangent of radical 3, we know that our argument is going to be pi/3. Okay, and so now we can write this as we've got 4, which is my modulus, and my argument is pi/3. Okay. I'm just going to let you see this. I'm going to zoom in a little bit so you can see a little better. You might want to hit pause, check your answers. Okay. Once again, we're going from polar to Cartesian form. I don't know why I said degree mode. This is not degree mode. You need to be in radian mode. Oh, I guess it's these two here you have to be in degree mode. This one here have to be in degree mode. And then the other three, they gave it to you in radians. They were trying to be tricky. Okay, check your answers. Check your answers. Please practice this with a calculator. Don't just copy this down. I want to make sure you get it.